For this video, we're going to be discussing factoring polynomials. So, how do we factor different polynomials? We've factored so far trinomials that are quadratic, so a degree of 2. For this video, we're going to be factoring higher level polynomials. So, how you factor a polynomial depends on how many terms it has. So the first thing you want to do is always factor out the greatest common factor. Then you want to look at how many terms your polynomial has. Okay, it's either going to have 2 terms or 3 or 4 terms for what we're going to be doing. If it has 2 terms, you're going to factor by pattern. I'll show you what that means in just a second. And if it has 3 or 4, we're going to factor by grouping, which is how we've always done factoring before. So let's deal with 2 terms. Okay, so factoring patterns. For 2-term polynomials, there are 3 different patterns we're going to be looking at. The first is difference of squares. So difference of squares looks like this, a squared minus b squared. So both terms are perfect squares, and they're being subtracted. That's really important. It has to be subtraction. It can't be adding. Both of these numbers have to be perfect squares. And the pattern looks like this. You've got a squared minus b squared, and that's going to equal a minus b times a plus b. So what I do is I do the square root of the first term, the square root of the second term, and I put the square roots here, and they go in each set of parentheses, and in one they're separated by a minus sign, and one they're separated by a plus sign. We also have difference of cubes, which is the same idea, except now it's perfect cubes instead of perfect squares. And the pattern for this looks like this. And this one's a bit trickier, but what we do is these are both perfect cubes, we do the cubed root of both numbers. So the cube root of a cubed is a, the cube root of b cubed is b, so it's a minus b. And then our second set of parentheses, you square the first term, multiply the 2 terms together, and square the last term. This sign should always be the opposite of this one, so this is a minus, this will be a plus, and this last one's always a plus. I say that because we also have a sum of cubes. So cubes can have a plus sign between them. And in the sum of cubes, you'll notice it's very similar to difference of cubes. I've got a cubed plus b cubed equals a plus b. So these 2 signs match. These 2 signs are always different. So if this is a plus, this is a minus. And then this one is always a plus. And it's still square the first term, multiply them together, square the last term. As we do practice with these, it will become more apparent how this works. Now, the nice thing about using these factoring patterns is that when you use them, what's left over will always be prime, so I can never factor this stuff any farther. So, if I take a look, here are some examples. It says factor each one of these polynomials. So for this one, this is x squared minus 16. So x squared is a perfect square, and 16 is a perfect square. So this is a difference of squares, so I'm going to square root both of them. Okay, when I square root them both, square root of x squared is x, square root of 16 is 4, and following our factor pattern, it's x minus 4, x plus 4. I just use the same 2 terms, one with a minus, one with a plus. Okay, if I look over here at x cubed minus 27, okay, 8 is a perfect cube, x cubed is a perfect cube, and 27 is a perfect cube. So I can use my difference of cubes here. So I'm going to do the cube root of 8x cubed and the cube root of 27. The cube root of 8 is 2, and the cube root of 27 is 3. And the cube root of x cubed is x, obviously. So the cube root of 8x cubed is 2x, cube root of 27 is 3, so it's 2x minus 3. And then in my other set of parentheses, it's going to work like this. I want to square 2x. So 2 squared is 4, and x squared is x squared. My next sign is always the opposite of this one, so this is a minus. The next one will be a plus. Then I multiply these 2 things together. 3 times 2 is 6x. And then my last sign is always a plus, and I square my last term to get 9. 3 squared is 9. This term is always prime, or this factor is always prime. It can't be factored anymore. All right, I'm going to do the same thing down here at the bottom. X cubed is a perfect cube, and so is 125. So I can do the cube root of both of them. Okay, the cubed root of x cubed is just x. Okay, these two signs should match. The cube root of 125 is just 5. And then I'm going to do this one very similarly to this one up here. First off, I'm going to square my first term, so I've got x squared. The next sign should be the opposite of this one, so minus. Then I multiply my two terms together, so 5x. The last sign is always a plus. And then I square my last term, and I get 25. So this is how we use patterns to factor two-term polynomials. Now, if we have a three-term polynomial, 3 or 4-term polynomial, we have to use grouping. And these are the same directions that we've always used when we factored quadratics. Okay, so we factor out a greatest common factor, we multiply a times c, we find two numbers that are factors of a and c, or of a times c that add up to b, and then we factor out each greatest common factor, factor out our common binomial, and then check to make sure that the new thing is that we need to check to make sure that the factors that come out cannot also be factored. Now these steps up here, which are kind of the hard part, we only have to do if we're doing a 3-term polynomial. If it's a 4-term polynomial, this is already done for us. We don't have to do it. So let's take a look at a couple examples. I want to factor each one of these. So this is a 3-term polynomial. So I need to go ahead and split up my middle term. So hopefully you remember we use our little x tool. Up top here I go 5 times 15. That's 75. And down here I've got negative 28. That's my middle term. So I need to somehow split negative 28 into two numbers that multiply to 75. They're both going to be negative, and it's going to be negative 25 and negative 3. Those are the two factors of 75 that add to negative 28. All right, so I just split it up like this. 5x to the fourth minus 25. This is a squared, so I make them squared. 25x squared minus 3x plus 15. Now I'm just going to do greatest common factor here. So if I do my greatest common factor of 5x to the fourth and 25x squared is 5x squared. And if I divide these out, if I go 5x to the fourth divided by 5x squared, the 5's cancel. X to the fourth divided by x squared is x squared. Similarly, if I divide this one by 5x squared, 25 divided by 5 is 5, and the x squareds cancel. Negative 3x squared and 15. Remember, we always factor out the sign of the first number, so I'm going to factor out a negative 3. So negative 3x squared divided by negative 3. These cancel, and I just have x squared. 15 divided by negative 3 is negative 5. Then I just go ahead and regroup them. X squared minus 5, what's inside goes in one set of parentheses. 5x squared minus 3, what's outside goes in the other set of parentheses. And now I need to check, because these have squareds in them, I have to check to see if they can be factored. Because they have two terms, the only way they can be factored is if both of these are perfect squares and both of these are perfect squares. X squared is a perfect square, but 5 isn't, so this can't be factored. 5x squared, well, 5 is not a perfect square, and neither is 3, so this can't be factored. So that's it. That's my answer. All right, this one over here, 4x cubed plus 12x squared minus x minus 3, this is a 4-term polynomial, meaning I can skip this whole step of splitting up my middle term. I just want to work with the 4 terms I'm already given. So I'm going to look at my first two terms, and I'll be like, okay, the greatest common factor of 4x cubed and 12x squared is 4x squared. 4 goes into 4 and 12, x squared goes into x cubed and x squared. So I'm going to divide each one of these by 4x squared. And 4x cubed divided by 4x squared, the 4's cancel. X cubed divided by x squared is x. Over here, 12 divided by 4 is 3, and my x squareds cancel. Then if I look at negative x and negative 3, the only thing they share is a negative, so I'm going to factor out a negative 1. So I'm just going to divide them both by negative 1. Negative x divided by negative 1 is positive x. Negative 3 divided by negative 1 is 3. So then I'm going to go ahead and regroup these into x plus 3 times 4x squared minus 1. Now x plus 3 cannot be factored because this isn't a perfect square and this isn't a perfect square. 4x squared minus 1. 4 is a perfect square, x squared is a perfect square, 1 is a perfect square, and they've got a minus sign here. So I can use difference of squares, my pattern, to factor this. So the square root of 4x squared, square root of 4 is 2, square root of x squared is x, square root of 1 is 1. So this becomes 2x minus 1 times 2x plus 1. So this actually has another step where I have to factor again, and my answer ends up being x plus 3 times 2x minus 1 times 2x plus 1. And this is how you can factor polynomials that have a degree which is bigger than 2.